What is engineering? Let's take a moment to think about your morning. The alarm on your phone goes off at 7:03. You drag yourself to the shower and blast yourself with perfectly warm water in an attempt to wake up. You smear your toothbrush with too much toothpaste and scrub yourself into a foamy mess of minty freshness. You're running late, so you skate downtown, weaving through the commuters, dart across the road, barely making the lights, and jump on the train just before the doors beep shut. There's a couple of stops to go, so you pull out your phone and play a few games of Angry Birds. Alarms, trains, traffic lights, video games, toothpaste, all these things were made possible by engineers. But what prompts an engineer to improve our world? Well, they solve problems. Problems are an engineer's inspiration, and maths and science are the creative tools they use to solve them.
You are living in a world of creation. The things you use and see around you is created by people, and most creators are engineers. Okay, what is engineers? Engineers figure out how things work, understanding the natural world and using it to invent, design, and to solve problems. Traditionally, the main branches of engineering are civil engineering, electrical engineering, mechanical engineering, and chemical engineering. But there are many more other specializations, which we will discuss it later on. Civil engineering deals with construction and maintenance, like building, roads, tunnels, airports and bridges, and water supply. Electrical engineers design, develop, and test of electrical control system and machinery and equipment. Chemical engineers apply the principles of chemistry to solve problems involving production or other use of chemical and other products. Mechanical engineers research, manufacture, and test tools, engines, machines, and other mechanical devices. Those are the main branches of engineers, but we have lots of branches of engineers nowadays. And we have aerospace engineers. They design aircraft, spacecraft, and satellites. And we have biochemical engineers. They develop health-related problems. We have agricultural engineers. They develop agricultural machinery and equipment to help farmers. And we have environmental engineers. They develop solution and environmental problems. And we also have health and safety engineers. They are responsible in treatment, diagnosis, and prevention. And we also have computer engineers manage installation of computer hardware, including computer chips, circuits board, computer system, and related equipment such as keyboards, routers, and printers. The work of computer engineer is similar to electronic engineers in that they may design and test circuits and other electronic components.
In our daily lives, we are curious about how these products produced. Even in my childhood, I always seek myself how these things work, what are the processes and procedures, and who are the makers of this product design. That's why I built my interest to be an engineer. We all know that there's a lot of engineer, not just mechanical engineer or computer engineer, but there's a lot of it. Air conditioning was designed by mechanical engineer. Computer was designed by computer engineer. Producing a lot of products made our economy more productive and efficient with the use of this product design and with the help of engineers. Engineering field has a lot of contributions in our economy, community, and in our country. Try to look at your surroundings. We notice that there's a lot of product made by engineers, lot of machines with different designs, lot of products that we use in our daily living. Engineer cannot produce these products without enough knowledge and experience. Before they conduct this process, they prepared and planned everything such as the tools and procedures. Being skillful is good, but having a common trait of good engineer is the best. It is very important for an engineer to have good personality in order to achieve their goals. There are several traits of good engineers. Number 1, curiosity. Building curiosity means building interest. Curiosity of something, how this product's done, and what are the functions in its parts. This kind of curiosity will build our interest to seek more knowledge about this field. They want to know generally on how these products work and function. Once they have enough knowledge and experience this field, they can add up or upgrade a new one which are more advantageous and efficient to use. Number 2, critical thinking. Being critical thinker are more likely to succeed on their works because they can handle the situation with wise and effective decision. They assess, analyze, and synthesize data to meet the objectives. I believe that you cannot succeed without failures, but you must face the failure to proceed in the next stage. We must be wise in our decision and develop our critical thinking skills. Number 3, creativity. Being a good engineer must have creativity to all the works they've done. To be creative, we must be passionate and have the love on our works. Another thing, being creative are more unique than a copy one. The creative spirit of an engineer are more likely to succeed and have the good works. Number 4, effective communication. Ideas are very important to deliver the message they wanted to convey. Ideas are not useful if you cannot present effectively to others. Effective communication skills is one of the good traits of good engineer because they know how to present their ideas to their teammates, co-workers, or even in the management. Having an effective communication is the key to achieve the goals and objectives. Number 5, a collaborative spirit. In engineering field, you cannot work alone. Apply creativity and collaborate ideas are more likely to succeed and continue. There are many engineers who are successful in their profession because they know how to collaborate, exchange ideas, and develop successful plans. If an engineer works alone, there is a lot of tendency to experience difficulties as the challenges arises upon their works.
There are the types of engineering disciplines. First, acoustical engineering, also known as acoustic engineering. It is a branch of dealing with sounds and vibration. Agricultural engineering is the area of engineering concerned with the design, construction, and improvement of farming equipment and machinery. Architectural, also known as building engineering, is an engineering discipline that deals with the technological aspect and multidisciplinary approach to planning, design, construction, and operation of buildings. Biochemical engineering, also known as bioprocess engineering, is a field of study with roots stemming from chemical engineering and biological engineering. Broadcast engineering is the field of electrical and computer engineering which deals with radio and television broadcasting. Ceramic engineering is the science and technology of creating objects from inorganic, non-metallic materials. Civil engineering is a professional engineering discipline that deals with the design, construction, and maintenance of the physical and naturally built environment. Climate engineering is the intentional large-scale intervention in the Earth's climate system to counter climate changes. Computer engineering integrates several fields of computer science and electronic engineering required to develop computer hardware and software. Earthquake engineering design and analyze structures such as buildings and bridges with earthquakes in mind and to make structures more resistant to earthquake. Electrical engineering deals with the technology of electricity, work on a wide range of components, devices, and systems. Engineering research concerned with the discovery and systematic conceptual structuring of knowledge. Forensic materials engineering, a branch of forensic engineering, focuses on the material evidence from crime or accident scenes, seeking defects in those materials. Health system engineering is an area of research in healthcare delivery science that examines system and process design. Information engineering deals with the generation, distribution, analysis, and use of information data and knowledge and system. Marketing engineering is currently defined as a systematic approach to harness data and knowledge to drive system marketing decision making. Mining engineering is extraction of minerals from underneath, above, or on the ground. Petroleum engineering concerned with activities related to the production of hydrocarbons, which can be either crude oil or natural gas. Planetary engineering is the application of technology for the purposes of influencing the global environment of a planet. Polymer engineering is generally an engineering field that designs, analyzes, and modifies polymer materials. Quality engineering concerned with the principles and practice of product and service quality assurance and control.